Hi everyone, let's talk about traditional computing versus the power of AI. This is an incredibly important video. It might be one of those aha moments when you realize how something really works. When I deeply understood what I'm about to explain, I started to truly grasp the inner workings of AI. Imagine this. Two teams are trying to predict the weather. One is using a massive supercomputer, crunching billions of calculations for hours. The other, just a single AI model running on a laptop, making predictions in minutes. This is the power of AI versus traditional computing. And it is not just about weather. AI is transforming finance, healthcare, manufacturing, and more by replacing rigid, rule-based systems with models that learn and improve over time. Let's dive in. We will take the weather prediction problem as an example today because I think it is much easier to explain things in concrete terms. So buckle up, grab your umbrella, because for next half an hour we will talk about the weather and whole a lot about AI. We will talk about the problems with traditional computing, how AI is completely different, and then we will go beyond weather to discuss AI in various business applications. Stay until the end, because I promise you, this might be really one of those aha moments. So, the problem with traditional computing. Why do traditional weather prediction models require so much computation compared to AI-based models? To answer this, let's start by understanding how traditional weather models work and why they demand massive amounts of processing power. Before AI, weather forecasting relied entirely on physics-based models. These models take the entire Earth's atmosphere and divide it into a grid. Each grid cell represents a small portion of the atmosphere, and the model applies complex mathematical equations to simulate how weather conditions evolve over time. Temperature, air pressure, wind speed, and humidity are calculated at every single grid point, and these calculations are repeated over and over again, step by step, to simulate how weather will change in the coming hours and days. This might sound simple, but there's a massive challenge here. The atmosphere is incredibly complex. Every small change in the temperature or pressure can have a ripple effect that influences the weather miles away. To capture these interactions, models need an enormous number of grid points, sometimes in the millions, each requiring calculations at every time step. There are differential equations that describe how air moves, how heat is transferred, and how moisture turns into clouds and rain. The more accurate the forecast needs to be, the finer grid resolution must be, meaning even more calculations. Because of this, traditional weather models require some of the most powerful supercomputers in the world. These systems, often made up of thousands of CPUs, work around the clock solving billions of equations. And despite all of this, forecasts still take hours to generate. A typical global forecast for the next 10 days might take 6 hours to compute, or even more. That means if a hurricane suddenly changes course, meteorologists could be stuck waiting for updated predictions at the time when every second counts. Now let's compare this to AI. AI models don't rely on solving physics equations from scratch every time. Instead, they learn patterns from vast amounts of historical weather data. By recognizing how certain weather conditions led to specific outcomes in the past, AI can make fast, data-driven predictions without needing to simulate every tiny detail of the atmosphere. This is what makes AI so much faster. While traditional models take hours, AI models can generate forecasts in seconds using a single high-performance GPU instead of an entire supercomputer. Another major issue with traditional models is their dependence on complete and structured data. If a sensor or satellite goes offline and fails to provide data for a certain grid point, the entire model can become less reliable. Traditional models don't handle missing data well because they rely on precise, continuous inputs. AI, on the other hand, is much more flexible. It can fill in gaps intelligently by analyzing surrounding data points, ensuring that predictions remain stable even when some information is missing. So, why do traditional weather models require so much computation compared to AI? Because they are trying to simulate reality from the ground up, using equations that must be solved at every single grid point for every moment in time over and over again. This brute force approach demands massive computing power, enormous amounts of energy, and hours of processing time. Meanwhile, AI takes a completely different approach. Instead of relying on equations, it recognizes patterns, making predictions in a fraction of time with far fewer computational resources. But here's the key point. AI is not just faster, it also continuously improves. Traditional weather models don't learn from past mistakes. If they make an incorrect prediction, they don't adjust on their own. Meteorologists must manually refine their models, tweak parameters, and rerun simulations. AI, on the other hand, learns. If it makes an incorrect prediction, it updates itself based on real-world outcomes, improving its accuracy over time. That's a game changer. Think about it this way. If a traditional model is like trying to calculate the trajectory of every single raindrop in a storm, AI is like having seen millions of past storms and knowing what is likely to happen next. One approach requires endless calculations. The other simply applies learned knowledge. That's why AI is revolutionizing weather forecasting and countless other industries. Traditional models will still have their place in long-term climate simulations, where detailed physics calculations are necessary. But for real-time weather forecasting, emergency predictions and high-speed decision-making, AI is proving to be a superior tool. And as AI continues to learn from more data, its predictions will only get better. This is why more and more meteorological institutions are shifting to AI-powered forecasting models. Understanding this shift is critical for anyone who wants to see how AI is changing the world. Weather forecasting is just one example of how AI outperforms traditional computing. The same principles apply to industries like finance, healthcare, and manufacturing, where AI is replacing old, slow, rule-based systems with fast adaptive intelligence. In the next section, we'll dive deeper into how traditional weather models work, exploring the actual equations they use and why they are so computationally expensive. Stay with me, because this is where things get really interesting. How traditional weather models work. Do traditional weather models recognize patterns, or do they only rely on step-by-step calculations? The short answer is that traditional weather models do not truly recognize patterns the way AI does. Instead, they rely on massive amounts of step-by-step calculations based on physics equations. Weather forecasting has always been a numbers game. The fundamental idea behind traditional models is to take the laws of physics, break the atmosphere into millions of small grid cells, and apply mathematical formulas to simulate how air, moisture, and energy move over time. This approach doesn't involve recognizing patterns or making predictions in the way humans or AI models do. Instead, traditional models simulate reality one step at a time, solving equations repeatedly for every grid point at every time interval. Let's consider wind movement. In the real world, wind moves because of differences in air pressure. Traditional models use differential equations to calculate the change in wind speed and direction at every grid point. If one area has higher pressure and another has lower pressure, the model calculates how the air should move between them. Then, it moves forward in time and does the same calculation again and again, step by step, slowly simulating how the wind moves across the atmosphere. Temperature works the same way. If the sun heats up the surface in one region, the model must calculate how that heat spreads to neighboring areas and how much is absorbed by the ground, how much rises into the atmosphere, and how it interacts with wind and humidity. This process repeats over and over, constantly updating as new calculations influence the next set of conditions. Now, you might ask, isn't that kind of recognizing a pattern? Not really. Traditional models don't remember previous weather events or generalize what might happen based on past storms. Instead, they start from scratch every single time. Every forecast begins with fresh data, and the model must go through all its equations again. It doesn't learn or adapt based on previous forecasts. It just follows the numbers. And this is a key limitation. Traditional models are incredibly powerful for simulating reality, but they don't have the ability to evolve or improve their predictions based on experience. If a model gets something wrong today, it doesn't adjust itself to do better tomorrow. Meteorologists have to step in, analyze errors, and manually tweak the equations or grid sizes to improve accuracy over time. This is where AI fundamentally changes the game. Unlike traditional models, AI does not need to simulate each atmospheric interaction step by step. Instead, it learns from the vast amounts of historical weather data and identifies complex relationships between different weather variables. When given new input data, AI doesn't start fresh. It already understands patterns from millions of past weather events and can instantly generate an accurate forecast without going through billions of calculations. In short, traditional weather models are powerful, but they do not recognize patterns in the way that AI does. They are rule-based, running strict calculations every time they are used, without the ability to improve on their own. AI, on the other hand, is dynamic. It can analyze decades of weather history, understanding underlying trends, and refine its predictions with each new forecast. And that's why AI is becoming the go-to tool for modern weather prediction and beyond. So, let me tell you, a few days ago I attended the AI UK 2025 conference at the Alan Turing Institute here in London, where top AI scientists from across the UK gathered, including representatives from many renowned universities. Hundreds of doctors and researchers in the field were present. I spoke with one researcher who discussed the problem of weather prediction. He mentioned that a few years ago, AI couldn't outperform traditional models. However, in the past year, AI has almost always outperformed this older model. Moreover, instead of relying on supercomputers such as EU's Jupiter, which cost approximately 500 million and is located somewhere in Germany, you can now run AI models on a single GPU. Isn't that incredible? Let's now talk about how AI is different and why is it more efficient. How can AI predict future weather? The key difference between AI and traditional weather models is that AI doesn't need to process time step by time step like a physics simulation. Instead, AI learns from historical weather data, so it has already seen patterns that occurred over many years. When an AI model is given a new input, it compares it to past situations and instantly recognizes what is likely to happen next. It doesn't need to calculate how each variable evolves over the time because it already understands the likely outcomes based on past patterns. So how does AI-based weather prediction work step by step? First, AI models are trained on massive datasets containing past weather conditions, including temperature, humidity, wind speeds, and pressure. These datasets come from historical weather records, satellite images, and sensor networks. AI learns to associate specific weather patterns with their outcomes. For example, it might learn that a certain pressure drop combined with rising humidity usually results in storm. When AI receives real-time weather data, it doesn't start from scratch. It already knows from past experience what will likely happen next. AI weather models typically use deep learning architectures such as recurrent neural networks, RNNs, and transformers. RNNs are well suited for time series predictions because they can retain information from previous time steps. However, newer architectures like transformers have proven to be even more effective because they can analyze long-term dependencies in weather patterns without the limitations of sequential processing. I mentioned RNNs and transformers, but for the average viewer, and believe me, I often fall into this category too, these terms might feel abstract. So let's explain what they do in plain English. Imagine a neural network like a giant web of tiny decision makers, each making small judgments based on what they've seen before. Think of it like how your brain learns. When you see a dog, you don't analyze every detail. Your brain instantly recognizes its shape and movement and other features because it has seen dogs before. AI works the same way. A neural network is made up of layers of artificial neurons that process information step by step. The first layer might look at basic details, let's say temperature, pressure, humidity. The next layer finds relationships between them, and the final layer makes a prediction. And over time, as AI sees more and more examples, it learns which patterns matter and becomes better at making predictions. That's why AI weather models don't need to recalculate everything from scratch. Here's something really interesting. We don't actually know what exactly AI sees. Unlike traditional models where we explicitly program every step, AI finds its own relationship in the data. It might detect tiny, hidden connections between temperature, humidity, and pressure that we could never even think to look for. But here's the kicker. We don't need to know how it does it. We only care about the results. If an AI model constantly makes more accurate weather predictions than the traditional methods, then it is doing something right. Back to our video. When an AI model processes incoming weather data, it outputs a probability-based forecast rather than solving equations step by step. For example, instead of computing how every air particle moves over time, AI might predict that there is a 80% chance of rainfall in some regions, and all based on past patterns. This means that AI-based forecasts are generated in seconds and not in hours. How is AI trained for weather prediction? The training process begins with feeding historical weather data into the model. AI looks for relationships between different variables and learns which conditions lead to specific outcomes. This is done through supervised learning, where the model is given input data along with the correct answers. Over time, AI adjusts its internal parameters to make more accurate predictions. The more data it is trained on, the better it gets. Once trained, AI can process new weather data and make accurate predictions without needing to solve complex equations. Now, let's compare AI models with traditional models in terms of computation time and required resources. Traditional models require supercomputers with thousands of CPUs working together, often taking several hours to produce a forecast. In contrast, AI models can generate forecasts in seconds using just a single high-performance GPU. This efficiency allows AI to update forecasts much more frequently, giving meteorologists real-time insights rather than waiting hours for an update. In summary, AI is fundamentally different from traditional weather models. It does not rely on step-by-step simulations, but instead recognizes patterns from vast amounts of historical data. It uses advanced neural networks to generate rapid and accurate forecasts without needing massive computational resources. AI is not just faster, it continuously improves as it learns from new data, making it the future of weather prediction and beyond. Now let's talk about business applications beyond weather. AI's ability to recognize patterns and make real-time decisions isn't just transforming weather forecasting. No, it's revolutionizing industries across the board. Businesses that once relied on rule-based systems or traditional modeling are now seeing AI-driven solutions outperform older models in efficiency, accuracy, and speed. Let's start with finance. Traditional stock market analysis relies heavily on historical trends, human intuition, and present trading rules. But AI-powered trading systems operate differently. They take vast amounts of financial data, detect subtle patterns that humans would miss, and execute trades in milliseconds. AI-based hedge funds consistently outperform traditional ones. Now, consider healthcare. Traditional medical diagnosis depends on doctor analyzing symptoms and doing medical tests to determine a diagnosis. While experienced doctor can recognize patterns from years of practice, they are still limited by human memory and bias. AI changes this by analyzing thousands of patient records. AI model can detect early signs of diseases such as cancer, often with greater accuracy than human specialists. Another industry undergoing rapid transformation is manufacturing. Traditionally, factories perform maintenance based on set schedules, whether a machine needs it or not. This often leads to unnecessary downtime or worse, unexpected breakdowns. AI-driven predictive maintenance eliminates guesswork by analyzing real-time sensor data to detect early signs of wear, and AI predicts exactly when and where maintenance is required, reducing downtime and saving companies millions in operational costs. AI is even reshaping transportation and urban planning. Traditional traffic management relies on fixed schedules for traffic lights, which means congestion builds up even when roads are clear. AI-driven traffic control systems use real-time camera feeds and sensor data to adjust traffic signals dynamically. So, all these examples highlight a fundamental shift. AI is no longer just a futuristic concept. AI is redefining what's possible. Companies that embrace AI at this moment will have a significant competitive advantage over those that stick with only traditional methods. The future isn't coming, it's already here, and AI is definitely leading the way. That's all. Thanks for watching. See you in the next one. Bye.